Okay, 11.6, simplifying radical expressions. Do you remember perfect squares? Perfect squares are when the same number is used as both factors. It's the product that results. So like 7 times 7 is 49. What the heck? Right? 18 times 18 is 324. That's the perfect square. The perfect square is the product. The factors are the square roots. Okay, for our vocabulary, we have something called a radical expression. It's not an equation, it's just an expression. All that means is that there is a square root sign. And then we have something called the radicand. The radicand is whatever's underneath the square root sign. This is the radicand. Make sense? A radicand can be numbers, it can be variables, it can be numbers and variables. When you look at a radical expression, how do you know you're done simplifying it? If the radicand has no perfect square factors, so whatever's under the hood here, there's no perfect squares. So if I had 25x, is that simplified? No, because 25 is a perfect square, right? That would turn out, so this is not simplified. The radicand has no fractions. So if I had this 3 over, let's say 5, because I just love drawing curves with this thing, is this simplified? Nope, you can't have a fraction inside as your radicand. How about if I had something like 4 over the square root of x? This is also not simplified. You can have no square roots in any denominator. You might want to write that stuff down. Pause this and write it down. Okay, square roots are very romantic. It takes two that are the same to go out. If they're not the same, they can't go out. And if there isn't two of them, they got to stay home under the roof too. Okay? So let's try 24. Let's put 24 into its simplest radical form. So if we want to say 24. 24 is the same as 8 times 3, right? And 8 is the same as 2 times 2 times 2, because 2 cubed is 8. Now everything is prime. These two are exactly the same. They can go out. What are we leaving at home? The 2 and the 3. Square root of 6. So if this was the square root of 24, this would be the answer. I don't know why this is on that presentation. It's dumb. Oy. Remember though, the two have to be the same, and then they can go out. What about the leftover? So here we have x cubed to the square root of x cubed y to the fourth. That's the same thing as saying the square root of x times x times x times y times y times y times y. I need to get out the stylus now. Because it's charging. So these two x's, these two y's, and these two y's are all the same, right? These two x's can go out and they become one. Ooh, romantic. Two sets of y's. So that's going to be y squared. So there's two sets. What has to stay home? This poor X has to stay inside all by himself. He's been quarantined. Poor guy. And there's that answer. Now, if we want to simplify an operation under a radicand, you want to do the operation under the radicand first, and then take the square root. So what's 256 divided by 4? 64. So this is just the square root of 64. What's the square root of 64? 8. And over here, this is the operation under the radicand, 40 plus 9. So we got the square root of 40 plus 9 is 49. The square root of 49 is 7. And that was easy. Let's try these. Here we have 2 divided by 50. We can't really do much here, can we? But we can simplify them because they're both even, so we can divide them both by 2. So we'll have the square root of 1 over 25. And then there's more we can do with that later in a second. Okay, and here, when we look at this, what's the operation? 8 squared plus 15 squared. 8 squared is 64. 15 squared is 225. 64 plus 225 is 289, right? What's the square root of 289? 17. Now, when I first looked at this, I thought, oh, here's a square, there's a square, here's a square root. Square roots undo squares. Why don't we just call it a day? Just say this is 8 plus 15. But 8 plus 15 is not 17. 8 plus 15 is 23. That means this is not 23, it is 17. That doesn't work. Do the operation that's the radicand first. All right, what about this mess? What do you see? I see a perfect square trinomial, don't you? You could do this if you want to. Oh, crap. I don't know where I was. Anyway, we have a perfect square trinomial under the hood. What can we do to a trinomial? We're going to have to factor that, aren't we? If you want to do the x, you can. -6, +9. You can see easily that this is -3 and -3, right? So that means the two factors that we're multiplying together are x minus 3, x minus 3. So we're doing x minus 3 squared. However, because it's a square root, we don't know if it's positive or negative, do we? Because this one might be positive and this one might be negative. This might be positive and this one might be positive. This might be negative, this might be negative. We don't really even know. So if it counts positives and negatives, we're going to go with the absolute value of x minus 3. Make sense? I hope so. Okay, that's if it's a simple operation as the radicand. What if we have a product property?